Hello everyone, and on this video we will cover the distance and midpoint formulas. Okay, so now starting off with the distance formula, I'm going to give you a quick overview as to how that is calculated. So we're going to pick 2 points, and let's say we want to know the distance between those 2 points. Okay. Now we don't know the value or the actual numbers for those, so we'll call these points x1, y1, and point x number 2 and y number 2, just to give it some explanation. Alright, so this point being x1 and y1 means your x value, your first x value, will be right there, and your first y value will be right there. So if this would have been 0.25, this would have been your 2, and this would be your 5. Okay, same thing with x2, y2. That means your second x value is right here, and your second y value would be right there. Let me kind of clean that up a little. There we go. Okay, so if we kind of get that y value and bring it out, we'll notice here that from this y value, your second y value, all the way down to your first y value, y2 minus y1, we'll make that equal your actual y value. Okay, so if your second y value was 5 and your first y value was 2, 5 minus 2 would give you 3. So your y value, your distance for y would be 3. Okay, same thing with the x1 and y1 here, the distance between your x2 and x1. Your x2 minus x1 will make that equal your x. So if your second x was 7 and your first x was 3, 7 minus 3 would give your x a distance of 4. Okay, so if you notice here, just going from this y value up to this y value up here, we now have kind of a right triangle. And whenever you have a right triangle, you can use the Pythagorean theorem, which means that x squared plus y squared equals your z squared, or your hypotenuse is your z. Okay, so we have our x squared, but instead of x squared, we're going to use x2 minus x1 squared because we don't have an x value. We just have those 2 points. So instead of x squared, it's x number 2 minus x number 1 squared. Same with the y. We don't have a y value, but we have our y number 2 and our y number 1. So that's y number 2 minus y number 1 squared. And our z is our hypotenuse, which is this, but since we're using a distance, we're going to make that d instead of z. Okay, so instead of z squared, we're just using d squared because it's our distance formula. So if we square root both sides, so we end up with the square root of x2 minus x1 squared plus y2 minus y1 squared. It's going to equal the square root of d squared, or our distance squared. Now normally when we square root it, we use a plus or minus, but your distance will never be negative, so we don't need the minus. So square root of d squared, the square and the square root cancels out. So I'm just going to flip that around and put the distance equals to x2 minus x1 squared plus y2 minus y1 squared. And this is actually our distance formula. Move that up. Okay, now all of this was just the explanation. The only thing you actually need to solve for the distance is that. Okay, so you don't have to do this for every problem. You just need that formula. Alright, so if you're still writing, please feel free to press pause, but we're going to go ahead to our first example. Okay, so for our first example, we want to find the distance between the points -2, 3 and 4, -5. Okay, now the first thing you have to do is for your -2, 3 and 4, -5 is you have to appoint an x1, y1 and an x2, y2. It doesn't matter which one you use, but you can make this your x1 and this your y1. You can make this your x2 and this one your y2. If you wanted, you could have made this one x2, y2 and this one x1, y1. You would get the exact same answer, so there's no wrong choice. Okay, now we know that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so if we plug everything in, that distance will equal the square root of x2, which is 4, minus x1 minus -2 squared, plus y2, we have -5 minus y1 minus 3 squared. Okay, so that will equal 4 minus -2 is 4 plus 2, so that gives us 6 squared, plus -5 minus 3 is -8, so that would be -8 squared. Okay, so that would be the square root. 6 squared is 36, plus -8 squared is 64, which would equal the square root of 100. Square root of 100 is, remember, that's plus or minus 10, but you can't have a distance that's negative, so that would just be positive 10. All right. Okay, so let's go ahead to our next example. If you're still writing, please feel free to press pause. Okay, so what if we wanted to find the distance between the points 2746 and 3350? Alright, so again, first thing we want to do is we want to assign our x1, y1 and x2, y2. Okay, so I'll make this my x number 1 and this one my y number 1. And 33 my x number 2 and this my y number 2. And just plug those into our formula. Remember, the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so going ahead and plug everything in. X2 minus x1 will be 33 minus 27 squared. Y2 minus y1 is 50 minus 46 squared. Okay, so we end up with 33 minus 27 is 6, so we have 6 squared, plus 50 minus 46 is 4, so that's 4 squared, and 6 squared is 36, plus 4 squared is 16, so that gives us the square root of 52. Okay, now that actually can be simplified because square root of 52, we can make that equal to the square root of 4 times 13. Okay, now once we factor those out, we can go ahead and separate square root of 4 times square root of 13. Square root of 4 is 2, so we have 2 square root of 13. So this just becomes 2 square root of 13. Alright. Okay. So once again, if you're still writing, please feel free to press pause. But we're going to go ahead to our next example, which is involving the midpoint formula. Okay, now the midpoint formula, let me kind of clean that up a little bit. So that's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So the idea behind the midpoint formula is, once again, if you have your point x1, y1, and x2, y2, your midpoint formula is the middle of your x and and your y midpoint. There we go. Alright, so let's jump right into the example. We want to find the midpoint of the line segment with the endpoints -2, 5, and 4, -2. Okay, and solving this is almost identical to solving for the distance, where the first thing you want to do is get your points, and you want to assign your x1, y1 and your x2, y2. And again, I'm just going to make this our x1, make this our y1, make this our x2, make that our y2. Okay, and we're just going to plug it into our midpoint formula. Okay, so your midpoint formula, remember that's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And we just plug it in. So x1 plus x2 is just -2 plus 4. You have -2 plus 4 divided by 2. And your y1 plus y2 is 5 plus -2. So 5 plus -2 divided by 2. Oops. Okay, so -2 plus 4 is +2. So we have 2 divided by 2. And 5 plus -2 is +3. That gives us 3 over 2. Okay, so 2 divided by 2 is 1. And 3 divided by 2, you can make that 1 1/2, or you can just leave it as 3 divided by 2. And this is your midpoint. Okay, so if you plot these 2 points on a graph, this point will be right in the middle of them. Alright. Okay, so hopefully these formulas in this video made sense, and I will see you on the next video.